Here's question 2A and 2B on the back of the Calorimetry 1 sheet. So the first one is telling you the heat of reaction for the following equation. So it's telling you the delta H is negative 68 kilojoules. Remember, that's per mole of reaction. When aqueous silver nitrate, that's that, containing 40 milliliters of 0.2 molar AgNO3 reacts with enough HCl to make the total mass solution 100 grams of coffee cup calorimeter, the temperature increases from blank to 23.5. So we're trying to figure out what that initial temperature was. It would be below this because it's saying it's increasing. And then it gives you the specific heat of the solution. So we might think, oh, I'm going to do Q equals MC delta T. You know, we have a specific heat. We have the mass of the solution. We're trying to figure out really this change in temperature. We also need to know Q. So first thing I do is figure out how much heat is released from this much silver nitrate. So let's get this into moles. We know every mole of silver nitrate releases that much heat into the solution. So if we go 0.04 liters, every liter contains 0.2 moles of AgNO3, and every mole of AgNO3 releases 68 kilojoules of heat. Every mole of AgNO3 produces 68 kilojoules of heat. So we can figure out how many kilojoules of heat are released. That is 0.544 kilojoules. So now we can plug that in there. But remember, specific heat is in joules. So let's put this into joules, it'll be 544 joules. So we go 544 equals the mass of the solution is 100. Specific heat is 4.18. And let's just go, what is the change in temperature? So take this divided by these two things, and your change in temperature is 1.3 degrees Celsius. Well, I want to know what was the initial temperature. Temperature increases from blank 23.5. So 23.5 minus 1.3 is 22.2. So it would have gone up from 22.2 degrees Celsius to 23.5. So your little stoic will tell you how much heat was released. Put that heat in there to see what the change in temperature was from there. Next one, you have some silver nitrate and some hydrochloric acid. So it's giving you both those. So you probably need to know limiting reactant, what mass of AgCl would be formed. Not a thermochemistry question. You just got to figure out limiting reactant. So remember, you can multiply liters times molarity and get moles. Liters times molarity and get moles. Since it's a 1-to-1 ratio, whichever one is the least number of moles is limiting reactant. I would tell you that the limiting reactant ends up being, this ends up being 0.0675 moles. This ends up being 0.05 moles. So this is your limiting reactant. That's your limiting reactant. And then it wants to know what mass of AgCl would be formed. Well, it's a 1-to-1 ratio, and then just turn it into grams. Answer there is about 7.18 grams. Peace.